So part of the art of doing a derivative is recognizing whether you need product rule or chain rule, or if you need both. So in the previous video, we walked through some examples where you needed both and how you would manage that. So this one, I'm not going to actually do any derivatives. I just want to look at these and try and pluck out the features that will tell me whether I need product or chain or both in order to get it done. So the first idea is hunting for things inside an argument. So every function needs an argument. Let me write that word down up there for you. Argument. That's the thing inside the function. So when you are looking at a sine or a ln or an exponential, it's always the ln of something or the sine of something. And you're watching me fail at trying to write and talk at the same time. So it's always ln of something. There has to be something inside that bracket, and that thing there, whatever's sitting inside the function, that's the argument. You need chain rule if the argument is anything other than a straight up x. So I'm going to go through these functions up here, and I'm going to examine the argument of each piece, and I'm going to see if any of them are complicated enough to require chain rule. So if I start looking, the argument here inside this radical is just an x. No problem. I don't have to worry about chain rule for that one. The argument inside this function, this sine, is just an x. So that's not complicated enough to need chain rule. So in this example, I'm not going to need any chain rule because the arguments are simple. If I go to this next function, 1 over x squared minus 3x, which I can rewrite as x squared minus 3x to the exponent -1, the argument of this to the -1 function, that's here, right? You look at what's inside. That is not just an x. That's some other function that's been shoved in there. So I'm going to need chain rule for this one. If I look at this particular one, inside the e, the argument on the e is just an x, so that's fine. The argument on this square root is just an x, so that's fine. But the argument on the sine is a square root of x. There's a function shoved inside of that sine, so I'm going to need chain on this one. Down here, the argument of the radical is an x, which I don't need chain rule for, but the argument of this sine is a square root x, which I'm going to need chain for, and the argument of this ln is a sine x, or sine root x. So I'm going to need a 2-layer chain rule for that one. So if you start drawing loops around the ever-expanding function, right, watching it get more complicated, if you end up with loops inside of loops, then you're going to need to use chain rule because you have a function nested inside the argument of another one. So having gone through this list, I can see that all 3 of these are going to require chain rule when I do the derivative, but I do not have to worry about it for the first one. So the second thing to hunt for is your product rule, whether you need that. So for product rule, you're looking for a complete function, including an argument, multiplied by some other complete function, including an argument. So if I look at this one, if I can split this like so that on one side of that line there is a complete function, right? The function name and an argument. On the other side I have a function name and an argument. This is 2 complete functions being multiplied together. This one requires product rule. If I look at this one, there's no multiplication at all. And if there's no multiplication, then I'm not going to need product rule, so I can skip that one. If I look at this one, I have an e to the x multiplied by sine root x. So I'm going to cut this here. This e to the x is a complete function with an argument. This sine function is a complete function with an argument, and they're multiplied together. So I'm going to need product for this one. Down here, if I try and cut this, right? If I tried to see a lawn, I try and cut it like this. Do you notice that I have separated the lawn from its argument? And that's not allowed, right? Like, this thing has to be a complete function. So I can't do that. Looking in here, if I tried to split the sine from this, I've done it again. I've separated the argument from the function, and that's forbidden. So there's nowhere in this bottom one where you have a complete function multiplying a second function. And that's sort of a tricky way to, or a tricky thing to get through your head, is that this is not ln multiplied by sine. It looks like it because they're pressed together. This is ln of sine, and this is sine of square root. Product rule only applies when you have root x, when you have something times something else, right? Or multiplied by something else, whichever word you want to use. If you have something of something else, that's not a product, that's a chain rule. So looking at these four functions that are up there, this first one, because it had simple arguments, I do not require chain rule. Because I could split it as a function times a complete function, I need product. This one requires product rule only. This function had no multiplication of any kind, but it did have a complicated argument inside of the rational expression, so I will require just chain rule for this one. This function could be separated into a complete function multiplied by a complete function, and this half, this complete function over here, happened to have a complicated argument. So I will need product rule because of the multiplication, as well as chain rule because of the nested argument here. In the final one, there is no multiplication of any kind, so product rule does not apply, and I have a two-layer function in the argument, so I'm going to have to apply chain rule twice.